Alright, welcome to the fourth video. Here we're going to be talking about a special type of trinomial, and that's the perfect square trinomial. And there's actually two different forms. There's when we have a plus b squared. When you do that, it has the form that, because you remember what this means, if we have a plus b squared, it means a plus b times a plus b. Let me kind of write that over up here above. We're looking at a plus b times a plus b. Well, if you FOIL it, we know we're going to have an a plus a, or a times a gives us a squared. And we know the last two terms are going to be b times b gives me a b squared. But what's our middle term? Well, if we take our inner product, we have a times b. And if we take our outer product, we have a times b. So we have two a times b's. So our middle comes out to 2ab. We also have the perfect square trinomial a minus b squared, which is very similar. This always multiplies out to be a squared minus 2ab plus b squared. And I have a couple of examples here. Example, factor. Example A, x squared plus 16x plus 64. Well, how we're going to be using these perfect square trinomials is actually going the opposite direction. We're going to be going back to this direction from right to left. And this is a plus and plus, so it's got to be the top example. And really what it is, what we're looking for is because, okay, x times x gives me x squared. And what squared gives me 64? 8. And our two middle terms should be 2 times twice what the first and second terms are. So what's 8 times x? 8x. And it's twice that, it's 16x. Which is what we wanted here. So 8 times x gives me 8x, but I take twice that, and twice 8x is 16x. So this actually factors out into x plus 8 times x plus 8, or x plus 8 squared. One more example here. A squared minus 10a plus 25. Well, how do we get a squared? It's got to be a times a. And how do we get 25? It's got to be 5 times 5. But we actually have negative 10a in here in the middle, so this has got to be negative 5. Okay, so a squared is a squared. Negative 5 squared is 25. Negative 5 times a is negative 5a, but I have two of those, so it's negative 10a. So there's your answer. Now, keep in mind that we could also do these the way that we've already always done them. I could try to write it out like this, and I could ask myself, what times what gives me a squared? Well, it's got to be a times a. What times what gives me 25 and adds up to negative 10a? Well, it's got to be negative 5 and negative 5. Negative 5 times negative 5 is positive 25. Our inner products give me negative 5a. Our outer products give me negative 10a. So there we go, we got that. So that's an example of perfect square trinomials. Our other type of special trinomials to factor are what we call difference of square trinomials. Difference of square trinomials. I'll give you just a second longer to copy that down if you're still looking at it. And we're going to move on to the next one here. Difference of squares. Okay, a difference of squares trinomial always has the form that if we start with a squared minus b squared, something squared minus something squared, this factors into a plus b times a minus b. And these are probably the easiest type to factor. Example, if I take x squared minus 25, that's x squared minus 5 squared. That factors into, again, we want to think of this 25 as 5 squared. So we do have a difference of squares. We have something squared minus something squared, x squared minus 5 squared. So that becomes x plus 5 times x minus 5. There's your answer. X plus 5 times x minus 5. That's as easy as that. Again, 5 times negative 5 gives me negative 25. And the reason why there's no middle x term is because what happens when I multiply 5x and the two outers give me negative 5x. What's 5x and negative 5x? 0x. The difference of squares, those two middle terms always cancel out. Let's take a look at another one. If that was example A, example B here, if we look at, let's say, one that's a little bit tougher here. How about 2x to the 4th minus 18x squared? Well, that doesn't look like a difference of squares here when we first look at it. However, what should we always look to try to do first? We should always look to try to factor out the greatest common factor first. And both of these have a 2x squared in common. When I factor that out, I'm left with x squared minus 9. X squared minus 9 is a difference of squares because 9 is 3 squared. So that means if I bring the 2x squared out in front down, using my difference of square rules, this has got to be x plus 3 times x minus 3. Okay, one more example here. Example C. If I take a look at 4x squared minus 9, this is again a difference of squares, not quite as obvious maybe, but this is the quantity 2x squared, and then this one is 3 squared. So this actually factors to 2x plus 3 times 2x minus 3. Again, because our first part squared is not 4x, our first part squared is 2x. So it's got to be 2x and 2x. And then the last part, we're subtracting 3 squared. 9 is 3 squared, so this has got to be plus 3 and minus 3. Hopefully that looks all right. That brings us to the end of our examples of factoring different types of trinomials. We have one more video left, and in the last video we're going to be looking at the idea of factoring a sum and a difference of cubes. A sum and difference of cubes. Alright, so we'll see you on the next video.